4-4. Today we're going to be talking about simplifying algebraic fractions. So this is going to be pulling on the lesson from last lesson when we had to find the greatest common factor of two numbers. Now we're going to do that, but the two numbers that you're going to be finding the factors of are part of the fraction, so the numerator and the denominator. Now, simplest form is when the GCF of the numerator and the denominator is 1. So basically you're taking out the GCF, and that's what you're left with. An algebraic fraction is a fraction with variables in the numerator and denominator, or denominator. So anytime you say something about algebraic, you know that it is going to have some sort of variable with it. So this form is like there's variables in your fraction. Alright, an example of putting a fraction in simplest form is right here. So your fraction is 9/12. So basically we need to figure out, can we simplify it anymore? So we need to go ahead and find the prime factorization of 9, which is 3 times 3, and the prime factorization of 12, which is 3 times 2 times 2. So now this is what we did last lesson. You go ahead and find the greatest common factor. So we have a 3 up here and a 3 down here. So that shows us that 3 is our greatest common factor. So we need to go ahead and divide it out of the numerator and denominator, and we are left with 3/4. So 3/4 is the simplified form of 9/12. So basically, 9 and 12 had a number in common. We took it out, and now this is as small as you can make the fraction. Now, an example of an algebraic fraction is over here. You have the numerator is 3 times x, and then over 5. So this is a fraction. We have our numerator, our denominator, but we have our variable, which makes it algebraic. So let's go ahead and do some more examples of simplifying both normal fractions with just numbers and algebraic fractions. Alright, our first fraction is 16/20. So automatically looking at it, we know that there is something that we can take out because both of these are even numbers. So let's go ahead and find the prime factorization of both 16 and 20. So if we break down 16, we have 4 times 4, and that turns into 2 times 2 times 2 times 2. So 2 multiplied 4 times is going to give you 16. Now when we break down 20, you have 2 and 10, and then 2 and 5. So you have 2 times 2 times 5. So let's go ahead. Here's the prime factorization of 16 and the prime factorization of 20. So now let's go ahead and find the greatest common factor. So there's a 2 over here and a 2 over here, a 2 here, and a 2 here. Now that's all they have in common, so we multiply 2 times 2, and that's 4. So we're going to take 4 out of the numerator and the denominator to get this fraction, which is bigger, into a simplified form. So this is as small as it can be. So we got to go ahead and take a 4 out, or divide 4 out of the numerator, divide 4 out of the denominator, and we're left with 4/5. This is now our simplified form of 16/20. Now, even though these two fractions don't look like each other, they're actually the same fraction. So it's just 16 out of 20 pieces instead of 4 out of 5 pieces. But it's still the same. If you thought of a pie, it would still be the same portion of the pie. It's just now simplified. Let's go ahead and look at 16/45. We're going to go ahead and take out the greatest common factor to simplify the fraction. So 16, we just did it up here, so the prime factorization is 2 times 2 times 2 times 2. Now 45, when you break it down, you have 5 times 9. You break down the 9 into 3 times 3. So 5 times 3 times 3. So here's the prime factorization of 45 and the prime factorization of 16. Now let's go ahead and circle what they have in common to find the greatest common factor. Okay, we have 2's here, and we have 5 and 3 and 3. There's nothing that we can take out. So that shows us that this fraction, even though the numbers are big, is simplified. So this is as small as it can be. Let's go ahead and look at number 3. It says 24/40. So we're going to go ahead and find the prime factorization of the numerator and the denominator to find the greatest common factor. So if we have 24, that's 6 times 4, and then 2 times 2, and then 2 times 3. So it's 2 times 2 times 2 times 3. That is a prime factorization of 24. Now we're going to go ahead and break down the number 40. 40 can be broken into 4 times 10, and then 2 times 2, then 2 times 5. So the whole prime factorization is 2 times 2 times 2 times 5. So that's the prime factorization of 40. This is the prime factorization of 24. Now let's see what they have in common. 2, 2, 2, 2, 2, 2. So we have 3 2's in common, and when you multiply those together, you're going to get 8. So we're going to go ahead and divide 8 out of both of these. So if you divide 24 divided by 8, you're left with 3. And when you divide 40 by 8, you're left with 5. So 3/5 is actually the simplified form of 24 over 40, which is kind of interesting. Alright, we're going to go ahead and switch gears a tad. Now we are going to go ahead, obviously these are algebraic fractions. So we're going to go ahead and take out the greatest common factor of both of the terms. So we're going to have to factor each monomial, and then we are going to go ahead and simplify. So obviously we could tell they have some things in common, like an A and a B already, just by looking at it. But we're going to go ahead and factor out each monomial. Okay, 28 can be broken down into 2 times 7, or 4 times 7, times A times B. 42AB, if you break down 42, you will have 6, which is 2 times 3, and 7 times A times B times B. So this is a prime factorization of 28AB, and this is a prime factorization of 42AB squared. So we're going to go ahead and see what they have in common. We have a 2 over here, we have a 7 over here, we have a 2 over here and a 7 over here, an A, and a B. So we are going to be taking out 14AB because 14AB is a GCF of the top number and the bottom number. So we're going to go ahead, and once you take 14AB out of the numerator, you're left with 2. And when you take out 14AB out of the denominator, you're left with 3B. So this is actually the simplified form of this fraction right here. So obviously you can see a little bit of how this is going to help you in the future. One way is just by the fact that this looks way less complicated than this. So if we can break this down a tad and show that it's not so scary, this is a lot easier to use. Let's go ahead and simplify this algebraic fraction right here. So a cubed y. Let's go ahead and find the prime factorization. It's x times x times x times y. The prime factorization of the numerator. Now let's find the prime factorization of the denominator. So we have x times y times z times z. So we have an x in common. We have a y in common. So we're going to go ahead and take both x, y out of the numerator and the denominator. So we'll be left with x squared over z squared. This is the most simplified form of this fraction. Alright, make sure that you have watched this full video, that you've taken your notes, and if you have a little bit of questions, rewind it, watch it again, or look in your textbook for some more examples. Now let's go ahead and do some on your own questions.
Good luck. We'll see what you got.